Okay, so we're going to do this practice exercise together where we are asked to calculate the pH at this volume and this volume of this having been added to this, which is literally the titration curve we just looked at, right? So basically we are, well actually let's write a reaction and make sure we're all clear here, right? So we have HNO3 plus KOH gives us this plus this. Okay, so then when we look at that, right, we know that we have 25 mils of 0.1 molar KOH, right? So 25 mils of 0.1 molar. And here we have also 0.1 molar, and we're going to do 24.9 mils versus 25.1 mils, right? And when we look at what that says, right, we are calculating the pH just before, because obviously since they're equimolar, equal constant, equal volumes are what's going to get us the equivalence point. So we are being asked to calculate the pH at the bottom of that steep rise versus the top of that steep rise, right? Which means that there's a chemical reaction that happens first, and then with what remains, right, because that's what happens, right? This reaction says that as my acid reacts with my base, it gets neutralized. So first we have to figure out how much is used, how much remains, and then with what remains, we would calculate the pH, right? How you want to do that is kind of up to you, right? A rice table works well for that if you like that. If you would prefer, you don't have to do a rice table. You could do some other method, just whatever works for you. We're just going to put this over here on the side so it's not in the way. Let's think about how many moles we have. So if we have 0.25 times 0.1, right? That would be 0.0025 moles, right? Initial, right? Versus here, if I have 0.0249, right? 0.00249 moles initially, right? And then, because this is a strong titration, right, it reacts completely. Yes, in that my titrant added is a strong species, it will react completely, right? Which means all of this is going to react, yes? Subsequently, that much of this is going to be consumed. Okay, so now we just need to figure out how much remains, which would be 0.00001 should be how many moles are left, right? Moles, and we have to be clear here when we use our units, right, that we are just quickly doing this in moles divided by 0.0499 liters, right? And this will give us the molarity of our KOH, which should be something on the order of 2 times 10 to the negative fourth, clarity, right? And then we would find POH, and then we would turn that into pH, right? And we should get 10.30 as our final answer, right? And we should stop and make sure that that makes sense, right? Because if we're doing a strong base titration, right, before we hit the equivalence point, right, we should be somewhere up here, right? So we should be somewhere in the very basic range still, right? So then that pH makes sense, right? And so this is where it's helpful always to stop and think about it, right? If you are a very visual person, like visualize and you need it on paper and you cannot see it in your head, right? It wouldn't hurt to go ahead and just doodle a quick titration curve, right? Because you can just do that on the side here really quickly, right? What's my initial pH, right? And if this is a strong base, right, versus a strong acid, right, what's it going to look like? You know, and just that way you have some visual point of reference for that titration curve so you can be more likely to get it right. Does that make sense? Okay, so let's go ahead and talk about that second scenario, right? So what we're going to do is we're just going to put a little line here. And in that second scenario, right, we still have 0.0025 moles of this, right? But now we have 0.00251 moles here, right? Which means that if it reacts completely, right, and here we do have to look at the numbers, right? So clearly we have more HNO3 than we have KOH, right? Which means that all of this gets consumed, leaving us with 0, right? And here, clearly, we will have 0.00001 moles of excess, right? Which will then divide by our volume, which will be 0.0501 liters, right? And then we'll turn that into a molarity and a pH, right? Oh, and this is HNO3 at this point, right? Clarity. Okay, and so we get this molarity, right, which we could then, and since now we have this, and this is our acid. We don't have to go through pOH, right? We would just do the negative log of that, and that would give us our pH, right? Which would be 3.70, right? So does that make sense, right? And that corresponds to this bottom part here, right? Where we would be 3.7, right? And that's sort of the bottom of that rise. Yes, does that make sense? Okay. All right. Thank you for listening. This is the section on strong acids and strong base titrations. And in the next section, we'll touch on how these differ from a weak acid titration. Thank you for listening. Be good, and I'll see you soon. Bye.